Hello everyone. I welcome you all in the journey of mathematics learning. In today's class, we are going to learn about the number system. So first thing is that whenever we will see something around us, definitely we'll start counting with the numbers 1, 2, 3 like that. So set of these types of numbers are actually known as the natural numbers which occurs naturally. You can see here 1, 2, 3 dot 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 till infinity, but remember that infinity is not a number. If it is positive infinity, it represents biggest value. If there is negative infinity, it represents smallest value. That means a kind of, we can say that the symbols to represent the numbers. Now, in the set of the natural number, if 0 is included in it, the another set will be formed. The name of that set is whole number. Similarly, if negative of these numbers, just like -1, -2, -3 till minus infinity are included in the set of these whole numbers, then it becomes set of integers. You might have learnt about this before also, but these are the things, these are the examples that comes under number system. Now next is that we just want to see what type of properties that we can get. Suppose you take any two natural numbers and add it up, whether you are going to get the natural number or not. Say for example, I just want to say that natural number plus natural number whether gives natural or not. For that, we can have some counter examples just like this. 2 is natural, 3 is also natural. If you add these two number, 5 is there, 5 is also the natural number. So sum of the natural numbers gives us the natural number. Next, what happens if you subtract any two natural numbers? Will you be able to get always the natural number? For that, you choose one number is 2, another number is also 2. 2 minus 2, it gives us 0. But 0 does not belongs to the set of natural number. That's why natural number minus natural number always may not be natural number. Clear? So it is clear that addition of the natural numbers are natural number, but the subtraction of natural numbers are not always natural number. So if you see for the product, if you multiply two natural numbers, definitely you are going to get the natural number. Similarly, if you check for the division of these two natural numbers, any two natural numbers, you are not going to get the natural number. You will be getting the fractional numbers. So the property that we have written is actually the closure property. The name of the property is SURE, closure property. So addition is closed in the set of natural number, subtraction is not closed in the set of natural number, multiplication, that means product is closed in set of the natural number, but the division is not closed in the set of the natural number. Now what happens if you choose the set of the whole numbers, whether we are going to get the same format or not? Examples are very similar and properties will remain, I think, same for this. For that, let's check it out. Let's symbolize the whole number with this W. Sum of any two whole numbers will give us whole number. It is clear. But whole number subtracted from another whole number, will it give us whole number again? In the previous example, जुन चाहिँ हामीले natural number को केसमा use गरेको थियौं, 2 minus 2, it gives us 0. 2 is whole number, 2 is whole number, 0 is also the whole number. In this case, हामीले यो केसमा के पाउँदैछौं भन्दाखेरि दुईटा होल नम्बरलाई सबट्र्याक्ट गर्दा होल नम्बर पाउँदैछौं. But if you have 2 minus 3, then it gives us -1, which does not belongs to the set of the whole number. That's why whole number minus whole number always may not be the whole number. So similarly for the product of any two whole numbers always gives us the whole number. For the division also same. If a whole number is divided by another whole number, we may not get always the whole number. So these are the things that we can see. We can find it out in case of these whole numbers and natural numbers. Now we will be checking in the set of integers. First one, integer plus integer. It always gives us integer. That means sum of any two integers are always an integer. Next, what happens for this subtraction? integer minus integer. Previously we have seen examples just like this: 2 minus 2 is equals to 0, 2 minus 3 is equals to minus 1. These are the examples that we checked there in the set of the natural number as well as in the set of the whole number. So we got these informations. Now to check this subtraction of two integers, whether we are going to get the integer or not. Look at here, 0 is also integer because 2 and 2 both are integers. 2 and 3 both are integers. Minus 1 is also an integer. It means that we can conclude that if an integer is subtracted from another integer, then always we are going to get an integer. Next, product, we already have seen that integer multiplied with the integer, it gives us always an integer, similar with the properties that we have seen for this natural number and whole number. And at last, integer divided by another integer may not give us always an integer. For that you can find it out one counter example just like this: 1 divided by 2, both are integers, but the fact is that 1 divided by 2 does not belongs to the set of the integers. These are the properties that we can obtain. That means these are the ideas related to the closure property in the sets of natural number, whole number and integers. Now we will move into the next form of the number set, where we can find it out these type of numbers: 2 divided by 3, 5 divided by 6, minus 8 divided by 9. Suppose these type of numbers are there. Even in the previous also we have seen that 1 divided by 2, a kind of fractional number is there. If we have these type of the number, what will be the name of the set containing these type of numbers? That is, you know that this is rational number. Now what is rational number? Rational number is that which number can be written in the fractional form. For the proper definition, you can look at here as a number that can be expressed in the form of p divided by q, where clearly it is mentioned that q should not be equals to 0 and p and q both should be integers. Then whatever number that we can form, that is actually the rational number. So the example of rational numbers we already have seen there in this set: 2 divided by 3, 5 by 6, minus 8 by 9. These all are the examples of the rational numbers. But the fact is that if you'll see this definition carefully, it consists of 3 sections. First one is a number should be written in the form of p divided by q. Second is q should not be 0. Number 3 is p and q, thus both the numbers should be from the set of the integers. If any number satisfies these 3 things, then we can say that the number is rational number. Every time whenever the rational number the topic that comes up, so most of the time we used to get that whether 0 is rational or not. For the confusion with related to the number 0, let us check it out here. For 0, whether first property is satisfied or not. Okay, 0 can be written as 0 divided by 1, 0 divided by 2, 0 divided by 3, anything other than 0, because denominator should not be equals to 0. So I have written here 1, so in the denominator there is no 0. So first property is satisfied. Second property is also satisfied as denominator is non-zero. Both numerator and denominator, you can see here, are from the set of integers. That means 0 is also an integer, 1 is also an integer. It means that 0 belongs to the set of rational number. Similarly, you just check it out. All the natural numbers are rational numbers, because every natural number can be written in the form of p by q, denominator non-zero, p and q are integers. Similarly, it follows there for the set of whole numbers. That means every whole number is rational number. Similarly, for the integers, every integer belongs to the set of the rational number. Now look at here, every time whenever you will see the definition of the rational number, the denominator should not be 0. What happens if denominator is 0? So first case is that 0 divided by 0. Another case is 0 divided by 1, and another 1 divided by 0. We already have seen 0 by 1 is 0. So this belongs to rational number. It's okay. Now what will be the value of 0 divided by 0 and 1 divided by 0? Look at here. In this case, the denominator is non-zero. That's why it went to the set of rational number. यो दुईटैमा हेर्नुस्, यो दुईटैमा तपाईहरुले के पाउनु हुँदैछ भन्दा चाहिँ डिनोमिनेटर 0. अब यस्तो खालको केसमा चाहिँ हामीले यस्तो खालको नम्बरलाई चाहिँ कसरी पाउनु, यो नम्बरलाई चाहिँ के नाम हामी राख्न सक्छौं, के एक्ज्याक्ट भ्यालु पाउन सक्छ भन्दा 0 ले 0 लाई डिवाइड गरौँ न. 0 how much are 0? 0 ones are also 0, 0 twos are 0, 0 anything will be 0. 0 anything will be 0, the remainder will be 0. So which proper exact value that we can write? That is not there. That's why we can say that this is indeterminate. Another 1 divided by 0. If 0 divides 1, 0 how much are 1? We don't have any that exact value. That's why this is undefined. It means that if the denominators are 0 in any case, then either we are going to get the number as indeterminate or undefined. 0 by 0 form, indeterminate form, 1 by 0 is undefined form. Forms. There are mainly two forms of the rational numbers. One is fractional form that we already have seen. Another is decimal form. Decimal form means the number which is just kind of examples that I am writing for this decimal numbers. 2.5, 7.42. These type of numbers will be there. So these also comes under the set of the rational number. Now next thing is that what or how we can convert the fractionals into decimals. So to convert fractionals into decimals, we have to divide it. On division, you can find it out whether first terminating decimal expansion we may get or non-terminating but repeating decimal expansion that we may get. Example 1 divided by 2. I have written there 2 divides 1. Decimal will be there. 2 5s are 10. Remainder is 0. Terminated but decimal expansion. So terminating decimal expansion. यो हुन सक्छ एउटा केस. यदि टर्मिनेट भएन भने चाहिँ के हुन्छ त भन्दाखेरि 1/3 अर्को एक्जाम्पल यहाँनिर छ. 3 divides 1 सपोज. डेसिमल लगाए 0, 3 3s are 9. रिमाइन्डर 1 नै आउँछ. फेरि 0 लगाए 3 3s are 9 किनभने एउटा डेसिमल लाग्छ नि एक स्टेपमा एउटा 0 फ्रीमा पाउँछ. इट विल कन्टिन्यू. यो गएकै हुन्छ, टर्मिनेट हुँदैन. तर रिपिट हुन्छ. तर रिपिट हुन्छ भन्दा एउटा कुरा के बुझ्नुपर्छ भन्दा चाहिँ सिंगल डिजिट मात्र रिपिट हुनुपर्ने कि ग्रुप अफ द नम्बर्स पनि रिपिट हुनुपर्छ भन्ने डाउट्स तपाईहरुलाई लाग्दैछ भने हेर्नुस् सेकेन्डमा 1 डिवाइडेड बाइ 7 यसमा सिंगल डिजिट मात्रै रिपिट भएको छैन, ग्रुप अफ द डिजिट्स रिपिट भएको छ. 142857 142857 डट डट डट. सो एनी नम्बर व्हिच सैटिस्फाइज either terminating decimal expansion, that also belongs to the set of the rational number. If the number has non-terminating but repeating decimal expansion, that also moves into the set of rational number. Clear? Hope it is clear to you all. Now for you, just check it out. 1 divided by 17. 1 divided by 17. 17 ले 1 लाई डिवाइड गर्नुस्. डिवाइड गरिरहनुस्. कति स्टेप्सको बादमा चाहिँ तपाईहरुले रिपिटेसन देख्नुहुनेछ, पाउनुहुनेछ. ट्राई गर्नुस् न. You will find it out. Next set of the number is irrational number. So irrational numbers is a number which has non-terminating and non-repeating decimal expansion. न त रिपिट हुन्छ न त टर्मिनेटै हुन्छ. जस्तो अब रेशनल नम्बरको एउटा प्रोपर्टी थियो जुन चाहिँमा कि टर्मिनेट हुन्छ भनेको थियो कि चाहिँ टर्मिनेट भएन भने पनि रिपिट हुन्छ डेसिमल्स त्यो एक्सपान्सनमा भनेर भनेको थियो. तर इरेशनल नम्बर भनेको चाहिँ त्यस्तो नम्बर हो जुन चाहिँ टर्मिनेट पनि हुँदैन, रिपिट पनि हुँदैन, डेसिमल एक्सपान्सन. इक्जाम्पल्समा √2, √3, √5, पाई एटसेट्रा. दो हामीले मेन्सुरेसन स्पेशली मेन्सुरेसनतिर पाईको भ्यालु 22/7 युज गर्छौँ p/q फर्ममा हुँदै पनि एक्ज्याक्ट भ्यालु 22/7 होइन, त्यो जस्ट क्यालकुलेसनको लागि एप्रोक्सिमेट भ्यालु मात्र युज गरेको। यु नो द्याट समटाइम्स वी युज द्याट पाई एज 3.14, त्यो एक्ज्याक्ट भ्यालु होइन, त्यसको नन टर्मिनेटिङ नन रिपिटिङ डेसिमल एक्सपान्सन हुन्छ। अब फेरि नन टर्मिनेटिङ र नन रिपिटिङ डेसिमल एक्सपान्सनको इक्जाम्पलको लागि एउटा सानो ट्रिक तपाईँहरूलाई बताउँछु ल। त्यो ट्रिक चाहिँ के हो भन्दाखेरि नि हेर्नुहोस् ल, 1.23 ऱ्यासनल कि इरेसनल भन्दाखेरि ऱ्यासनल टर्मिनेट भयो, डट 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 छैन नि त। अब मैले फेरि 2.3 भनेर लेखेँ, ऱ्यासनल कि इरेसनल, फेरि ऱ्यासनल, डट 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 छैन नि त। मैले सपोज डट 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 लेखेँ, के भयो भन्दाखेरि 2.3 सेम सेट रिपिट हुँदैछ, फेरि ऱ्यासनल भयो नि त। सपोज मैले यहाँनिर अझै एउटा 3 लगाइदिएँ, फर्स्टमा 2.3 छ, सेकेन्डमा 2.33, डेफिनेटली अर्कोमा 2.333 आउँछ, सो अन। सो सेम फर्मेटमा नम्बर रिपिट भएको छैन भनेदेखि यो नम्बरलाई पनि वी अल्सो से द्याट द इरेसनल नम्बर। सो इरेसनल नम्बर बनाउनु कति सजिलो होइन, एउटा डेसिमलको बादमा रिपिट नगरी लेख्नुहोस्। अब फेरि यस्तो लाग्छ नि, हाम्रोमा डिजिट जुन चाहिँ छ, हामीले नम्बर लेख्दा युज गर्ने 0 to 9, 10 वटा जुन चाहिँ डिजिट्स भनौँ न, 0 1 2 3 4 5 6 7 8 9, त्यति मात्रै छ, त्यति त रिपिट हुन्छ जहिले पनि। अन्त 10 स्टेप्सको बादमा त रिपिटेसन सुरु भइहाल्छ त, अन्त जस्तै पनि भन्दाखेरि त्यस्तो कन्फ्युजन छ भने त्यसमा चाहिँ मेन कुरा के हुन्छ भने सेम फर्मेटमा रिपिट भयो भने मात्रै हामीले त्यसलाई रिपिट भएको भनेर मान्छौँ। तर सेम फर्मेटमा रिपिट भएन भने चाहिँ त्यसलाई रिपिटेसन मानिँदैन। सेम फर्मेटमा रिपिट भएन भनेदेखि फेरि त्यस्तो नम्बरलाई के भन्छौँ हामी, इरेसनल नम्बर भन्छौँ। नाउ रियल नम्बर, the set which contains all the rational numbers as well as the irrational numbers, that a bigger set is known as the real number. So real number contains all the numbers, that means rational number and irrational number. All the numbers भन्दा फेरि सबै हैन भने फेरि rational number र irrational number। फेरि rational number भित्र को छ भन्दा rational भित्र integer छ, integer भित्र को छ, whole number छ, whole number भित्र को छ भन्दाखेरि natural numbers छ। Now in the next part, what we are going to see is that we already have seen the closure property for binary operations in the case of natural number, a whole number and integers. Let's try to do here in case of this rational number, irrational number and real number. First we will see for the set of the rational number. So rational plus rational is rational, rational minus rational is also rational, rational multiplied with rational is also rational, तर rational divided by rational always may not be rational। के कारणले गर्दा भन्दा यो सेटमा 0 छ, 0 अब 0 divided by 0 पनि प्रब्लम हो, some non-zero number divided by 0 is also, that does not belongs to the set of the rational number। त्यसले गर्दाखेरि rational number divided by rational number always rational number हुँदैन। कति बेला चाहिँ हुने रहेछ त भन्दाखेरि यो सेटबाट यदि यो जुन चाहिँ डिभाइजर सेट जुन चाहिँ छ, डिभाइजरपट्टि भएको सेटकोबाट चाहिँ 0 लाई हटाइदियो भने चाहिँ त्यहाँबाट चाहिँ रेसनल हुन्छ। त्यसको बादमा इरेसनल नम्बरको केस हेरौँ है त। यो रेसनल नम्बरको भयो, इरेसनल प्लस इरेसनल, कुनै दुईटा इरेसनल नम्बर, इरेसनल प्लस इरेसनल यस्तो हुन्छ। यसलाई अलिकति ध्यान लाएर तपाईहरुले बुझेर हेर्नुपर्ने हुन्छ। दुईटा इरेसनल नम्बर एड गर्दाखेरि सधैँभरि इरेसनल आउँछ कि आउँदैन भन्दाखेरि यसो सोच्दा त आउँछ जस्तो लाग्छ नि त। तर हेर्नुस् त, एउटा इरेसनल नम्बर स्क्वायर रुट 2 छ, अर्को इरेसनल नम्बर माइनस स्क्वायर रुट 2 छ। दुईटा डिफरेन्ट हो, साइन डिफरेन्ट छ, भ्यालु डिफरेन्ट छ। दुईटालाई एड गरौँ त, वी विल बी गेटिङ 0। तर 0 कस्तो नम्बर हो? रेसनल नम्बर। त्यसले गर्दाखेरि सधैँभरि इरेसनल र इरेसनल जोड्दाखेरि इरेसनल नै आउँदैन रहेछ। काउन्टर इक्जाम्पल यो भयो। सिमिलरली सबट्र्याक्सन गर्दा अर्को इक्जाम्पल हामीले लिन सक्छौं। जस्तो स्क्वायर रुट 2 एउटा भयो, अर्को स्क्वायर रुट 2 सेम नम्बर छ, दुईटालाई सबट्र्याक्ट गरौँ, वी विल बी गेटिङ 0, फेरि रेसनल नम्बर। सो सधैँभरि इरेसनल आउँदैन रहेछ। यो लेख्दा देख्दै म एउटा तपाईहरुलाई के भन्न चाहन्छु भन्दा, कुनै चीजलाई प्रुभ गर्नु छ, कुनै स्टेटमेन्टलाई प्रुभ गर्नु छ भने धेरैवटा अब क्राइटेरियाहरु फुलफिल भएको हुनुपर्छ। तर डिस्प्रुभ गर्नुको लागि चाहिँ वान काउन्टर इक्जाम्पल इज इनफ। जस्तो अब यसलाई डिस्प्रुभ गर्नु पर्दैछ एउटा काउन्टर इक्जाम्पल दिनुहोस् कुनै पनि चीजलाई डिस्प्रुभ गर्नु पर्दैछ भने वन काउन्टर इक्जाम्पल इज इनफ तर प्रुभ गर्नुको लागि चाहिँ थुप्रोवटा क्राइटेरियाहरु हामीले प्रुभ गर्नुपर्ने हुन्छ सो प्रोडक्ट इरेशनल प्रोडक्ट विथ द इरेशनल एउटा इक्जाम्पल फेरि त्यसको लागि पनि √3 मल्टिप्लाइड विथ स्क्वायर रुट 3 पावर हाफ हाफ छ दुईटैको सो प्रोडक्ट हुँदा लज अफ इन्टिसेसले पावर एड हुन्छ भन्छ पावर एड हुँदा 1 हुन्छ त्यसले गर्दाखेरि 3 को पावर 1 भइहाल्यो फेरि रेशनल आउँछ सो सधैँभरि इरेशनल आउँदैन रहेछ डिभाइड गर्दाखेरि पनि यो इरेशनल नम्बरको केसमा टेन्सन लिनु पर्दैन जिरो छैन त्यसमा डिभाइड गर्दाखेरि पनि हेर्नुस् स्क्वायर रुट 2 डिवाइडेड बाइ स्क्वायर रुट 2 त्यो त 1 आइहाल्छ जुन चाहिँ त रेशनल नम्बर भइहाल्यो त्यसले गर्दाखेरि इरेशनल डिवाइडेड बाइ इरेशनल पनि सधैँभरि इरेशनल नै आउँदैन रहेछ कोही कोही बेला रेशनल पनि आउँछ सो दिज आर द थिंग्स with the properties for the set of irrational numbers. Now we will see for the last one that is real number. For real number actually it satisfies exactly same properties of this rational number. Real number added with the real number gives always real number. अघि देखि नै यस्तै चलिरहेको छ real number minus real number real नै नहुन्छ real र रियल नम्बरको प्रोडक्ट गर्दाखेरि पनि रियल नम्बरै आउँछ रियल नम्बर डिवाइडेड बाइ रियल गर्दा सधैँभरि रियल नम्बर आउँदैन सधैँभरि रियल नम्बर नआउनुको कारण चाहिँ यो सेटमा 0 हुन्छ 0 ले कुनै नम्बरलाई डिवाइड गर्दैछ भनेदेखि अघिदेखि भनेकै छ कि अनडिफाइन्ड फर्ममा हुन्छ कि इन्डिटरमिन्ड फर्ममा हुन्छ त्यसले गर्दाखेरि रियल नम्बरमा चाहिँ यो क्लोजर प्रोपर्टी विथ रिलेटेड टु द स्ट्यान्डर्ड बाइनरी अपरेसन्स यो टाइपको रहन्छ अब नेक्स्टमा चाहिँ हाम्रो इम्पोर्टेन्ट पार्ट आउँदैछ है सो दिस इज भेरी मच इम्पोर्टेन्ट स्पेसली फर द क्लास 10 सीबीएसई क्लास 10 त्यो पार्ट चाहिँ के हो भन्दा चाहिँ रेशनल नम्बर र इरेशनल नम्बरलाई कम्बाइन गरेर स्ट्यान्डर्ड बाइनरी अपरेसन्स युज गर्ने फर्स्ट अफ अल एउटा तपाईहरुले रेशनल नम्बर लिनुहोस् अनि अर्को एउटा इरेशनल नम्बर लिनुहोस् दुईटालाई एड गर्दा के हुन्छ भन्दाखेरि इट अलवेज गिव्स अस इरेशनल नम्बर सो sum of a rational number and an irrational number is irrational. Similarly, rational number minus irrational number अथवा irrational minus rational it always gives us again the irrational. Subtraction मा पनि यो जुन चाहिँ यो माथि लेखेको छ एडिसन को जस्तो सम को जस्तो डिफरेन्स मा पनि त्यही रहन्छ सो सम सित रिलेटेड हामीले यहाँनिर डिफरेन्स पनि भनिराख्न सक्छौं नेक्स्ट जुन चाहिँ पार्ट अब हामीले पढ्नु आटेको छौं त्यो पार्ट चाहिँ के छ भन्दाखेरि चाहिँ प्रोडक्ट एउटा रेशनल नम्बर लिने एउटा इरेशनल नम्बर लिने दुईटालाई प्रोडक्ट गर्ने के पाउँछौं त हामीले रेशनल पाउँछौं कि इरेशनल पाउँछौं त्यसको लागि फर्स्ट वी विल सी वन काउन्टर एक्जाम्पल हेर्नुस् ल इफ आई हेभ रिटन 2 and another irrational number is square root 3 2 into square root 3 2 root 3 so that is irrational number एउटा एक्जाम्पल हेर्दा त इरेशनल नै आउने चान्सेस भयो नि त व्हाट हैपन्स इन प्लेस अफ 2 इफ 0 इज युज्ड 0 into square root 3 it gives us 0 now look at here 0 is rational number यसको मतलब rational number र irrational number मल्टिप्लाई गर्दा सधैँ भरि irrational नआउने रहेछ कुन चाहिँ कन्डिसनमा चाहिँ आउँछ त भन्दाखेरि यो जुन चाहिँ रेशनल नम्बरको सेट छ त्यसमा 0 हुनु हुँदैन त्यही कारण स्टेटमेन्ट यसरी लेखिन्छ प्रोडक्ट अफ अ नन जीरो रेशनल and an irrational is an irrational. So this non-zero part is very much important. यदि कुनै पनि स्टेटमेन्ट तपाईले लेख्नु हुँदैछ र नन जिरो लेख्नु भएन भनेदेखि यो स्टेटमेन्ट भ्यालिड रहँदैन। प्रोडक्ट अफ र्यासनल एन्ड इरेसनल इज अलवेज इरेसनल भन्नु मिल्दैन, किनभने र्यासनल नम्बरको सेटमा जिरो हुन्छ, जिरोले कुनै नम्बरलाई मल्टिप्लाई गर्दैछ भने इट गिभ्स अस जिरो, द्याट बिलोङ्स टु द सेट अफ द र्यासनल नम्बर। नाउ this is very much important. This statement is very much important to prove something as irrational number, and that comes under the syllabus of class 10 CBSE. For there you need to prove just like proving the irrationals. I should say that proving the irrationals. जहाँ तपाईले proving the irrationals गर्ने क्वेशन्सहरु भेट्नुहुन्छ, त्यो क्वेशन्समा कतिवटा क्वेशनमा यो स्टेटमेन्ट एकदमै बेसी युज भएको हुन्छ। कोही कोही बेला सीबीएसई बोर्ड एक्जाममा यो सित रिलेटेड क्वेशन्सहरु पनि हामीले बोर्ड एक्जाममा देख्ने गर्छौं। त्यसले गर्दा दिस स्टेटमेन्ट्स, द कम्बिनेसन अफ द र्यासनल्स विथ द इरेसनल्स आर भेरी मच इम्पोर्टेन्ट। सो फर डिभिजनको लागि पनि सेम जस्तै रहन्छ। जस्तो अब योबाट 0 लिनु भयो अनि यो चाहिँ नन जिरो छ भने त डेफिनेटली हामीले के बुझ्न सकिहाल्छौं, डिभाइड गर्दाखेरि र्यासनल नम्बरै आउँछ। त्यति बेला पनि याद गर्नुस् है, डिभाइड गर्दा एउटा नन जिरो र्यासनललाई इरेसनलले डिभाइड गर्दैछ भने इरेसनल आउँछ, कि चाहिँ एउटा इरेसनल नम्बरलाई नन जिरो र्यासनलले डिभाइड गर्दैछ भने पनि इरेसनल नम्बर आउँछ। Okay, these are the things, these are the properties that we need till here. The parts, the terms that we have learned today in this video are number system. There we have learned about the natural number, whole number, integers, rational number, irrational number, real number, their properties, especially closure property related to all these sets, as well as the properties that we can gather with the combination of the rational number and the irrational number, which is actually very much important. So these are the things that we have covered. So we will be looking into the more interesting things in the next video. Keep learning, keep practicing, because more you practice, more you learn is the Mool Mantra or main mantra of mathematics. Thank you very much. Thanks for watching.